Hello everyone, welcome back to another video. Today we're going to be looking at the grade 10 electrostatics question from the March 2025 paper. Question number 7. Two small identical spheres A and B are placed on insulating stands. Sphere A carries a charge of 3 Nc and sphere B has 4,375 times 10 to the power of 10 excess electrons. They've given us a diagram, and question 7.1 says, state the principle of charge quantization. Again, definitions, you have them. I won't go through them. Now, if you want to try these other questions by yourself, you can pause the video now. I'll go through the answers in 3, 2, 1. Okay, question 7.2, calculate the charge on sphere B. Okay, so they've given us the number of excess electrons. So in other words, they've given us the value for N. Now, we can calculate the charge if we have the N value. So question 7.2, we can say that the charge of an object, in this case, the charge of B, is going to equal the number of electrons that B has multiplied by the charge of an electron. B has 4,375 times 10 to the power of 10, and we are multiplying this by minus 1,6 times 10 to the negative 19. Now, I'm multiplying it by negative because remember, electrons carry a negative charge, right? And our answer is then going to be minus 7 times 10 to the minus 9 coulombs. Right? And remember, this makes sense. It needs to make sense because if the object has excess electrons, then it needs to be negatively charged. It needs to be negative. Right? So that makes sense. Also, another thing, times 10 to the power of minus 9. That is N. Nano, it means nano, right? And you'll see how we use that just now. So we could write this answer as minus 7 Nc. We could, though it's not necessary. Next, they tell us the spheres are allowed to touch and are once again separated. Calculate the new charge on sphere A. Okay, so when we're dealing with questions of charges touching, there's one simple equation that we use, and the equation is Q equals Q1 plus Q2 over 2. Okay, now A has a charge of 3, so it's going to be 3 nanocoulombs, then plus B has a charge of negative 7, so negative 7 nanocoulombs divided by 2. And the answer is going to be negative 2 times 10 to the negative 9 coulombs, or you could say negative 2 nanocoulombs. Now, it's important that you understand that this is going to be the charge on A, and it's going to be the charge on B. Both of them will have the same charge after contact, right? And that will always be the case. When two charged objects touch each other, after contact, they will both have the same charge. Okay, let's move on. So we've got some space here. It says, after sphere C is identical to spheres A and B, but is not charged. Okay, so let's just draw a simple diagram of what we have. We have A, B, and C. We worked out A and B, so A and B are currently minus 2 Nc, minus 2 Nc, and then C is 0. It's not charged. Okay, they tell us that sphere B is rubbed with a woolen cloth, and thereafter brought into contact with sphere C. Once separated, both sphere B and sphere C have a charge of minus 3 Nc each. Determine the number of electrons that were transferred from the cloth. Okay, so this question involves us having to work backward. Okay, so let's look at what happened. So we have B, right? Then B, there's B, and minus 2 Nc, and then they brought a cloth. So it was rubbed with a cloth, right? And after it was rubbed with a cloth, it then got a new charge. But we don't know this charge, right? And then after that, we know that this new charge of B came into contact with C. And then after that, they both had a charge of minus 3 Nc. Okay, so what we can do is we can work backward, and we can actually work out what this charge here was. So let me show you how we do that. So we can say that Q equals Q1 plus Q2 over 2. Now we know the charge after contact, so that's minus 3, right? And it's Nc, so minus 3 times 10 to the negative 9. And that's equal to Q1. Let that be B. We don't know what that is, right? So let's leave it, right? Let's leave it as Q1. Then plus Q2, we know C was 0, so plus 0 divided by 2. Now we can work out what this charge is. So we'll say Q1 equals 2 times minus 3 times 10 to the minus 9. That's minus 6 times 10 to the minus 9. So what this is telling us is that after the woolen cloth was rubbed on B, B had a charge of minus 6 Nc, right? And that's good, because now what we can do is we can work out the number of electrons that were transferred during the contact, during the rubbing, right? So now it's just a matter of working out the number of electrons transferred. So let's write out the information that we know. We know initially, before the rubbing, right, before the cloth was rubbed, it was minus 2 times 10 to the negative 9. We know after it was rubbed with the cloth, it's minus 6 times 10 to the minus 9. And we also know the charge of an electron is minus 1,6 times 10 to the negative 19. So the formula to work out the number of electrons that's transferred is equal to the final charge minus the initial charge divided by the charge of an electron. So the final charge was minus 6 times 10 to the negative 9, then minus 2 times 10 to the negative 9, and divided by minus 1,6 times 10 to the negative 19. And now if you put that in our calculator, we'll get an answer of 2,5 times 10 to the power of 10 electrons transferred. Okay, I hope you found this video helpful. If you did, please consider liking and subscribing. If you want me to do any specific paper or specific question, please leave it down in the comment section below.